How do we write a general solution for trigonometric equation? With the help of three examples, let us understand the strategy. With Anil Kumar. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up solution of three different questions, trigonometric equations, and we are going to provide general solution for each one of them. So we'll take up question number 4, question number 5, and then question number 6 from our set of 9 questions, right? So that's the set of 9 questions. We are going to take up question number 4, question number 5, and question number 6 in this particular video. So let's begin with the very first question, which is we have square root of 3 cosecant square x plus 2 cosecant x equals to 0. Let's factor cosecant x and we get square root of 3 cosecant x plus 2 equals to 0. Now each factor can be 0, giving a set of solutions, right? Now if I substitute the first factor as 0, we know for this one we have no solution, right? Clearly, cosecant x is either greater than equal to plus 1 or less than equal to minus 1, right? And for the other factor, which is square root 3 cosecant x plus 2 equals to 0, we can rearrange and write cosecant x as taking 2 on the other side becomes minus 2 over square root 3. So that will give us solutions, right? Now, I'll just save some space here. So we could rewrite this in terms of sign. So we have sine x equals to minus square root 3 over 2. So now we have to provide general solution for x when sine x is square root of 3 by 2 negative. Negative really means that we are working in quadrant 3 and 4. So we have solutions and these solutions are in quadrant 3 and in quadrant 4. We need to find the angle and then get the general solution. Now at this stage, you could actually look into unit circle for your answers, which I don't really recommend. I recommend special triangles, right? So at this stage, I recommend that you use special triangles. Always use special triangles for exact values. So we're looking at square root 3 over 2 for an angle. So this angle, square root 3 over 2, reminds you of special triangle 30, 60, 90 or pi by 6, pi by 3, pi by 2, right? So if you're working radians, then you can write this as pi by 3, right? So we know that the related acute angle is pi by 3. If you're looking up to the solutions of 0 to 2 pi or in one circle of 360 degrees, then the two are pi plus pi by 3 or 2 pi minus pi by 3. Right? So we have pi plus pi by 3 or we have 2 pi minus pi by 3. If you're working in degrees, you can write pi is 180 degrees, 2 pi is 360, pi by 3 60 degrees, right? Okay, great. So let's continue with radians for now. The idea is to provide a general solution. What I wrote here is two solutions within an interval from 0 to 2 pi. Now, how do I write general solution for this? Let's do that. So we can now write x as equal to, you see, for pi we are adding pi by 3, and for 2 pi, which is even, we are subtracting. So we can write this as n pi, right? Where n could be 1, 2, 3, 4, 0, minus 1, 2, 3, 4. So where n belongs to integers. Plus, for sine, we have this formula, minus 1 to the power of n times the angle. Now the first angle will be minus pi by 3, right? Because negative, right? So this is the angle which we are looking for. Cos inverse is only valid from minus pi by 2 to pi by 2, right? So negative values minus pi by 3. So that becomes the general solution for the given function. You can verify by putting different values of n that it works, right? If you're working in degrees, well, in that case, you will write 180n plus minus 1 to the power of n times minus 60 degrees. You get the idea. So that is how we are going to provide a general solution, one statement for this particular function, right? So I hope it is absolutely clear. Well, in case you want to learn from me directly, feel free to send an email on globalmathinstitute@gmail.com. Our students, as you know, are right there on the top. We can be part of your success. So send an email and get started. Perfect. Now let's take the second question, which is question number 5 in our list of 9. Now we have cos square x equals to 3 sine square x. Let's rewrite the question. Cos square x equals to 3 sine square x. Relatively simple. We'll just divide. And so we get, if I divide by cos square x, I get 1 equals to 3. Let me show it like this. I'll add a step here, okay? So we'll divide by cos square x on both the sides. So we have 1 equals to 3 tan square x. Or you can say tan x equals to plus minus 1 over square root 3. Clear? So we'll divide by 3 and then square root. Whenever you do square root, you have to write plus and minus, right? So that means we now have within 0 to 2 pi 4 solutions, because tan is plus minus 1 over square root 3, right? And again, I prefer to use special triangles, right? Very clear. So square root 3, 1, 2. Tan is 1 over, so this angle we are looking at now, which is pi by 6. Perfect. And solutions are right there for you, right? Plus and minus. Perfect. So now we see that tan has a period of n pi. Now, since we have plus and minus, what we could do here is write down a general solution as x equal to n pi, right? Plus or minus, because both sides is valid, and the angle is pi by 6. You see how simple it is? Or if you're working in degrees, you can write x equals to 180n plus or minus 30 degrees. Perfect, where n belongs to set of integers. Is that clear to you? So we have taken up the next example, which was on tan. Now, let's move on and take the next example, which is 2 sine 2x plus 1. So let's rewrite this question, which is 2 sine 2x plus 1 equals to 0. Let's isolate sine 2x. Sine 2x equals to minus 1 divided by 2. So we have the value of sine 2x as minus half. It really means that we are looking into what solution? In quadrant 3 and in quadrant 4. Both places will be negative. Now, since it is 1 over 2, we are again looking into a special triangle with sides 1, 2, square root 3, the angle being pi by 6 for us, correct? So, for pi by 6 as the related acute angle, as you can see, it could be pi plus pi by 6, or it could be 2 pi minus pi by 6. Makes sense, right? So that is going to be your angle. And what is going to be the solution? Well, remember, this time we are working with 2x purposely. It could be nx also, right? So in that case, how should I write the solution, the general solution? We had a similar example earlier, right? So think about it. So general solution will be, since we know that the angle is to be added minus pi by 6, right? So you say n pi plus minus 1 to the power of n times minus pi by 6. Is that clear to you? And the angle is 2x. For x, we are going to divide by 2, right? So we have n pi by 2 plus minus 1 to the power of n times minus pi by 6. Well, some of you must have by now noticed that I could have written minus here, right? X n pi by 2 makes sense. Minus 1 to the power of n times pi by 6. No harm. So you could write like this. Even the previous answer, you could have written like this. Perfect. If you're working in degrees, of course, x equals to pi by 2 is 90, right? So we'll prefer to write 90 first. N minus 1 to the power of n, and pi by 6 is 30 degrees. So 30. Is that clear to you? That is the way of writing a general solution for our trigonometric equations. So in this video, we have taken up 3 questions, and for the other set of 3 each, look in the playlist. You'll get them all. I hope with this you have understood how do we find general solution for any trigonometric equation. Feel free to write your comments, share your views. If you like and subscribe to my videos, it will be great. You can also contribute. Thanks a lot and all the best.